previously, we had talked about how to use the Thevenin equivalent circuit analysis approach to figure out what kind of newly propagating wave will show up when we change the status of an initially charged line. In this video, we're going to look at another way to figure out what that newly propagating wave is, and that is what we'll call the reflection coefficient analysis technique. So we're going to start by looking at the same example as the past videos. So we have a generator that has the corresponding impedance I'll just call ZG1. We have switch here. This goes into a transmission line. Characteristic impedance Z0. And then you have a load. And at t equals 0, the switch is going this way. We have it running all the way until we reach a steady state. And at t equals 1, the switch will get moved towards this ZG2 impedance and will also remove the source. Now, as a reminder, in the Thevenin equivalent analysis, we looked at the voltage at this junction Vj, and then we looked at the change in Vj after t equals 0 and use that difference to figure out what new wave ends up showing up and propagating down the line. In this approach, instead of looking at the voltage at the junction, instead we're going to look at VSS. I'll call this VSS smiley face. The reason is that this analysis can take place on either side of the transmission line. So this could be VSS plus or VSS minus. In this case, smiley face refers to the direction going into the line. Okay, so if we're on the left side of the transmission line, so on the left side, then VSS smiley face is going to be equal to VSS plus, because that's the side that's going into the line. If you're on the right side of the transmission line, then VSS smiley face will be referring to VSS minus, because it's a negative wave that's in the direction of going into the transmission line. And similarly, I'll just say the sad face is the direction going out of the line. So if we're analyzing on the left-hand side, then VSS smiley face, VSS frowny face will be referring to VSS minus, and the opposite for if it's on the right side of the line. So that's the one bit of new notation that I'll introduce here. Now, one thing, the nice thing is that the first two steps remain the same. So these are identical steps compared to our earlier video when we're talking about the Thevenin equivalent approach. First is you want to find VSS and ISS. Find the steady state that happens right before you flip the switch by ignoring the transmission line. So you just pretend like the transmission line doesn't exist. Use the voltage divider or Kirchhoff's voltage law to find it. And then also find the reflection coefficient ahead of time before you flip the switch. So the reflection coefficient on both ends. So this step is identical to the Thevenin equivalent analysis approach. The next step is also the same. Is you want to decompose VSS and ISS. You want to decompose VSS into the VSS plus component and the VSS minus component. So you do that by solving a system of two equations where you recognize that the two together, VSS plus plus VSS minus, is going to be equal to your total VSS, and then also the currents are going to be equal to the total current. So remember, you have a minus sign when you're trying to convert VSS minus into a current. You have to divide it by negative Z0 instead of just Z0, and that's going to be equal to ISS. And then just like we did earlier, this is now, we can multiply both sides by Z0. So you get this. So these are our two equations, and we can use that to solve for VSS plus and VSS minus. So again, these are the same steps. Now we're going to do something. Now this is where it deviates a little bit. So one of the things, the other thing that we have to calculate is that at the junction, once you change the switch, the reflection coefficient is going to change. So we find the new reflection coefficient. And then after that, we're going to calculate VSS smiley face at t less than 0 and t greater than equal to 0. So again, this is, in this case, this example here, VSS smiley face is referring to VSS plus, and vice versa. If you're going to calculate, if all your analysis is on the right hand side, VSS smiley face is referring to VSS minus. So let's start by looking at, if you're, before you flip the switch, VSS smiley face t less than 0 is going to be equal to the voltage source that you have, if any, t less than 0 plus, so you're going to have the voltage that's due to this, and then also the voltage from the reflected wave of the steady state voltage that's coming out. So plus gamma j of t less than 0 of VSS frowny face. Again, so this gamma j of t minus 0, if it's a generator end, that would be referring to this. If it's the load end, that would be referring to that. So in our case, in this example here, it's a generator end, so we would be looking at that value. Next up, you look at when t is greater or equal to 0, this new situation, your VSS t greater or equal to 0 is going to be any voltage source after you flip the switch. In this case, there isn't one. And then plus gamma j of t greater than equal to 0 of VSS minus. VSS frowny face. So again, you look at the voltage, you recognize that it's the voltage due to the source, and then as well as the reflection from the current reflection coefficient times the outgoing steady state wave. And then greater than 0, you write out the same formula. And then after that, that gives you the information you need to calculate the new wave. So find the newly launched wave. So V new at t equals 0 is going to be equal to VSS smiley face t greater than equal to 0, so the quantity that you find here. So that's this minus that. So minus VSS smiley face t less than 0. So the difference between these two is going to be your newly launched wave. And then you refer back to what you've learned previously. You draw the bounce diagram. And propagate the new wave. Now, I didn't go over as much background in the initially charged line because we kind of covered that in the Thevenin circuit equivalent analysis approach. So if any of this makes completely zero sense to you, you might start by going back and reviewing that. And then separately, these are kind of the more general formulations of these steps. And so it's a little bit harder to follow because it's written in such a way that it covers all situations. So I highly encourage you to, once you're done watching these 2 videos, to follow along with me through a few examples, and hopefully after that, you'll have a good grasp of how to do this kind of analysis.